Now we are in the last lesson, correlation and the linear regression. First, we're going to talk about the scatter diagram. What does it mean, a scatter diagram? A scatter diagram shows the relationship between two quantitative variables, and each individual in the data set appears as a single point. So when I want to do the scatter plot, I'm going to see points on the graph. You need to understand that here I'm working with two variables, not one variable. It's not like the preceding lesson. So to describe it, to describe the scatter plot, we need to first to see if the association, the spin association, it means it's positive or negative. We need to see the form of the diagram. Is it a linear equation? Normally it's linear, it's a line. And we need to see the strengths, if it's strong, weak, or it's moderate. So we're gonna we will see the graphs. So if you look at the first graph, you see that the points are increasing. Increasing, it means a positive correlation. If you see the second graph, it's going down, decreasing, so it's a negative correlation. And if you look at the last one, I cannot precise if it's decrease or increase, so as it's no correlation. So when I say positive, negative, or no correlation, it means I'm talking about the association of the graph. Now, if it's really as a straight line like this here, it could be like this or even decreasing. We say it's a strong correlation. So this is what we define the strength. When it's like this, it's approximately, I can draw a line in between. Look at it. So it means it's moderate. And when it's impossible, if I want to draw, it's impossible to draw a line in between. So we say it's a weak correlation. And also with the calculation, we'll discover also when it's weak, moderate, or strong. So if I want to calculate R, the correlation, normally we get it from the calculator, and also we can do it by calculation. So we're going to see the two methods now. Normally R is between -1 and 1. So it's 0 point something or minus 0 point something. If it's equal -1 or 1, we say it's perfectly negative or perfectly positive correlation. Now it's equal, if it's equal plus 0 0.8 or minus 0 0.8, we say it's strong positive, it's plus, or strong negative. If it's 0 0.5 plus or minus, we say moderately negative or positive. If it's, for example, plus 0 0.2 or minus 0 0.2, we say it's weakly negative or positive, it's a weak. And if R is equal to 0, there is no association at all. So this is the analysis of the correlation. Now, the linear regression or the regression line is very important. This line will help me to predict some value that I need if I don't have it in the table. And it also helps me to approximately join the points on the scatter plot. So it is used to find the equation of the line that best fits the data. To graph it properly, to draw the line, first you'll plot all the points, and then we name G X bar Y bar as the center of gravity. This one should belong to the line, so this is gonna be the first point on the line, and then you pick any other point or many points to draw the line. And you draw the line passing through G and passing through most of the points on the scatter plot to be able to have the perfect representation of the linear regression. Now, how are we gonna find the linear regression? We're gonna find it using the calculator. So for example, if I have this data here, I can use my calculator. If I plug in, and you see it in the class, if I put all the data, the calculator will give me the regression line. So I have this regression line, and I can see that when I draw it first, I have the center of gravity, and then I will graph it. If you graph line, you see that it's not exactly, the line doesn't, they are not very near to the line. It means it's a moderate positive correlation. It's positive because it's increasing, and it's approximately next to the line, so it's moderate. It's not a strong correlation, and it's not a weak. It's a moderate correlation. I will do another example. If I want to do the product mount correlation coefficient, so I have a formula. If I don't want to do it with the calculator, so it's covariance xy over covariance x, covariance y. To find the covariance xy or x or y, we need the sigma xy, the sigma x squared, sigma y squared, minus x bar, y bar, x bar squared, and y bar squared. All those values from the calculator, we can get it, and also we can get it manually. Or we can get it from the calculator, but sometimes I will ask you to do it manually. So this is an example for that. So using data from example 11, the preceding example, find the product moment correlation coefficient of the data. So here I need to calculate it. So you find X bar, you find Y bar. I can find it manually or by the calculator. Now I find the covariance of xy. It's sigma xy over n minus x bar y bar. I find the covariance of x, covariance of y, and then I just replace, and I got 0.8626. And this one will reflect what I said in the preceding example. I said it's a positive correlation. So I said it's a positive correlation, a moderate positive correlation, because already this is the line of it. And how it will help me to predict, for example, I can ask you, um, for example, for the for example, for the percentage, for example, 64, there is no 64 here. Predict the number of students. So I can replace just X by 64, and I can predict the number of students, the percentage of students in humanities exam. So it's just, it will help me. I replace X. Sometimes they will tell you for this percentage what was the number of English students. So also I can predict, I replace X and I will get Y. That's it, guys. See you in the next video.